All right, welcome back to Mr. Music's YouTube page. We are on Chapter 10, Lesson 3, so 10.3 and P175 in your practice book. So today's lesson we talked about classifying triangles based on the lengths of their sides. And there's three different classifications: equilateral, isosceles, and scalene. If you remember on 10.1, we talked about classifying triangles based on their angles. And so we had acute triangles, right triangles, and obtuse triangles. Think about it as any given triangle can have a first name and a last name. You can give it a name based on its angles, and you can always give it a name based on the lengths of its sides as well. Today we're going to focus on the lengths of naming a triangle by the lengths of its sides. So number one up here was done for us. This is an equilateral triangle. We see that prefix equa. That means that you're dealing with something equal. And all sides are the same length. So we can see 1 inch, 1 inch, 1 inch. So all the sides are the same. So that is an equilateral triangle. Isosceles triangle is a triangle with exactly two sides that are the same length. Easy way to remember this is isosceles. You have two eyes that are the same, and an isosceles has exactly two sides that are the same. Okay, can't have three sides, can't have one side, can't have four sides that are the same, just like you can't have three eyes or four eyes. You have two eyes that are the same. So an isosceles triangle has exactly two sides that are the same. And then a scalene triangle is a triangle that has no equal sides, or another way of saying that is all the sides are different lengths. So let's look at 2, 3, and 4. Number 2, we have 4 centimeters, 9 centimeters, 7 centimeters. So this is 4, that's different than 9, and is also different from 7. We have none of the same lengths here. So if it has no equal sides, it is a scalene triangle. Okay, number 3, we have 5 inches, 5 inches. So there's two sides that are the same, and 2 inches. So it has exactly two sides that are the same. And if a triangle has exactly two that are the same, it is isosceles. And number 4, we have 5 centimeters, 5 centimeters, and 5 centimeters. So we have two sides that are the same, but we also have the third side that is the same. So all three are the same. So if all the sides are the same length, it is that equilateral triangle. All right, going on down to number 5 and 6. Marcus drew a line from, sorry about that. Marcus drew a line from point Y to point W in the rectangle shown below. So we know it's a rectangle, so we know this side is going to be equivalent to this side, and this side is going to be equivalent to this side. We also know, again, I'm just pulling out what I know, rectangle is going to have all right angles. And all right angles. So those are the little boxes showing that each of those angles are right angles. And then he created two identical triangles. By drawing that line. So let's draw that line from point Y to point W. So here's point Y, here's point W. I'm going to use my post-it note as my straight edge to try to draw as straight a line as I can, starting up there in that corner where point Y is and going down to the corner where point W is. Ooh, that wasn't very good, was it? Let me try one more time. Okay, that was a little better. Okay, and then it says classify the triangles by their size, by the size of their angles, and by the lengths of their sides. So here's that case where we're going back to lesson 10.1. We have to look at the angles and we have to look at the sides. So we're giving it a first and last name. So we're looking at it based on its angles and based on its sides. So first and last name. And both of the triangles are identical. Told us that in the problem, created two identical triangles. So they're both going to have the same first and last name. Okay. So let's look at triangle YZW right here, this triangle here. So we know this side, we don't know the exact length, but we know it's the same as this, as we know line segment ZW is the same length as line segment XY because it's a rectangle, and we know line segment ZW has to be a different length than line segment YZ because again we're dealing with a rectangle here. So what about this line? Well, we have a right angle here, and the right angle, the line opposite the right angle, is called the hypotenuse, and that is always your longest line in a triangle. So the line opposite of any right angle is called the hypotenuse, and that's going to be the longest line of the triangle. So we know that these three lines, line segment YZ, line segment ZW, and line segment YW, all are different lengths. Okay, now since we cut this rectangle in half, I have 90 degrees, but that 90 degrees, that right angle, is made up of this angle and this angle. So we cut that 90-degree angle in half. So we have an acute angle here, an acute angle here, but we still have our 90-degree angle here. So based on its angles, both of these triangles are right triangles based on their angles, because remember, a right triangle has exactly one right angle. And then based on its sides, we have three different lengths, so none of the sides are equal. We look back at our definitions up here, it must be scalene. So both of those triangles are right scalene triangles. Okay, they're identical, they're just mirror images of each other. And I'm going to erase this, but again, you can always rewind if you need something back. All right, number 6. Is it possible to draw a triangle that is both obtuse and equilateral? Explain why or why not. Well, to explain it, I'm just going to model it. I'm going to try to do it, right? Can I do it? Well, let's see. Let's try to do it. So I'm going to, again, use my Post-it note as my straight edge. And since I know I need equilateral, I want to make all the sides the same length. So I'm going to make the sides of my triangle the length of my Post-it note. So I'm going to start at one corner of my Post-it note. And, sorry about that. And draw a line all the way along the edge of that Post-it note. Let me make sure I got my pen going. Okay, good. Here we go. So that's how long the Post-it note is. Now I want to make an obtuse angle, and if I went straight up from that line, that would be a right angle. And remember, a right angle is 90 degrees. Obtuse needs to be a bigger angle than that. So I need to make this angle go to the left a little bit. I need to move this angle, this line segment to the left, to tilt it left to make that angle bigger than 90. So I'm going to get rid of that line. I want to make it bigger than that, because an obtuse angle has to be bigger than 90. And I'm going to use my Post-it note again to make sure that the line is the same length as this line here that I've already drawn. So I'm going to use my Post-it note again as my, kind of like my ruler. It's maybe not absolutely perfect, but, but it's kind of hard drawing on my computer screen. Okay, so these two lines are the length of my Post-it note, and I have an obtuse angle here. So I have the obtuse angle. So far, I'm equilateral, right? This line is the same length as this line. Now I just need to close this triangle up, and I need to make sure that the line that connects these 2 points here, let's label our triangle. We have point A here. We'll say this is point B, and this is point C. So angle ABC is obtuse. Line segment AB is the same length as line segment BC. Now I need to connect point A to point C, but I want to make sure that it's the same length as line segment AB and line segment BC. So in order to make sure it's the same length, I'm again going to use the end of my Post-it note because that's what I use to measure the other 2 lines. And I'm going to start up at point A and try to get all the way down to point C, covering the length of my Post-it note. So my Post-it note stops right there. Ooh, that's an ugly line. Let me fix that. My Post-it note ends right there. So this line from A, and we'll call this point D. Line segment AD is the same length as AB and BC, but was I able to close off and make my triangle? No. So, is it possible? No. And then I have to explain that. The line opposite the obtuse angle will always be longer than the other 2 lines, or other 2 sides, we'll say. So what that means, going back, what that means is, here's our obtuse angle. So the line opposite the obtuse angle, on the opposite side of the triangle, has to be longer. In order to make it a triangle, it has to be longer than the other 2 sides, than this side and this side. So line segment AC has to be longer than line segment AB and line segment BC. So we mark it by 2 lines showing that this whole line is different than this line and this line. So now it can't be obtuse equilateral. It is instead obtuse. And last name would be isosceles because it has exactly 2 sides that are the same. This third line is larger, so it's obtuse isosceles. All right, thanks again for watching. I'll see you on the next one.